some important topics of complex analysis. Actually, it is not complex, it is advanced complex analysis, you can say. Not in your syllabus. This is not a part of your syllabus. Okay, shall we start? I think while teaching to that part, that is, I think I talked about Lee-Wallace theorem. So let us just quickly recall what is Lee-Wallace theorem. Yeah. What happened to this? Just wait a second. And this is just application of your Cauchy integral formula. Okay. Let f be a bounded entire function on C, then f is a constant. Then f is a constant function. Okay. So bounded entire function is a constant. This is the first Lee-Wallace theorem, most important theorem. And by using this fundamental theorem is also applicable. And one more thing, if your real part is bounded, then also you know that, see, if f equal to u plus iv is given, if u is bounded implies v is also bounded. I hope ये शायद हम लोगों ने किया था, v is also bounded. Do you agree? If u is bounded, then v is also bounded. So if u is bounded, then also the same theorem holds. At the place of f is bounded, there will be, if real part of function is bounded, then also the function will be constant. Correct? How will you prove this? If u is bounded, then v is also bounded. For an entire function, definitely. So if it is entire, then it will satisfy CR equation. If it satisfies CR equation, then what? Then you can easily prove that how u and v are related to each other. U is bounded, then v will be also bounded. And maybe some more corollaries of this only. I will be writing it. Okay, let corollary, say first one. Let f be entire such that f of z plus 1 equal to f of z and f of z plus I that is equal to f of z. Okay, for all z belong to C, then f is constant. So see, there are so many fixed points. F of z plus 1 is also f of z, f of z plus I is also f of z. If there are at least 2 points, then your function is constant. At least 2 point. 1 and I is not a special guy. You can say at the place of f of z plus a, f of z plus b, this is same as f of z. So there are 3 fixed point actually. The image of 3 point is same. Then also the function will be a constant function. One more, let f be entire if f is such that real part of f or imaginary part of f has no zeros, then f is constant. Then f is constant. Then also the function will be constant. If it has no zeros, that is the case. Yeah, okay, so that was if I see some more properties, then yeah, next theorem is actually identity theorem. Okay, what is the identity theorem? Let U be connected and open. Let A be a subset of U which has a cluster point. Cluster point for you can understand it is as a limit point. Cluster point in U. Let f comma g from U to C be analytic assume that f of z is equal to g of z for all z in A. For all z in A, then f will be same as g on the set U. Okay, look at this. U be a connected and open. Let A be a subset of U which has a cluster point. At least a cluster point should be there in U. And let f and g U from C be analytic. It should be analytic, and assume that f of z is equal to g of z for all z in A. If in that set A if they are equal, then we will say that f and g are same in that U. Same, you can reframe it actually. Eco, you can say a open set. If it is equal on that open set, then it will be. Next was maximum modulus principle or maximum modulus theorem, you can say. Maximum modulus principle. What is maximum? Let U that is in C be a connected open set. Open set, and let F is analytic in U. Let E belongs to U and R is greater than 0 be such that BAR is contained U. That is an open ball centered at radius R. It is contained in U. Assume that mod of f of z that is less than equal to mod of f of E for all z belongs to this interval BAR. Then also f is constant. Then f is a constant in U. Do you see, this is just application of previous theorem. In previous theorem it was if in the interval U f and g are same, then it will be same. Here what is this? In that interval, in that open ball, the function is bounded. So do you see Liebowitz theorem? This was saying that if you are having a bounded entire function, that must be constant. Bounded entire function must be constant. So here I am using that only. I have already told you this is entire, that is analytic in the U, and it is bounded in this domain. That means it will be constant. So if it is constant in that interval, so it must be constant in the upper set U. And that constant value will always be on the boundary of function. That is, mod f will attain its maximum on the boundary. One more part was that is Roshi's theorem. Similarly, same maximum के लिए है ना, same there will be some minimum modulus principle. What is that? If f is a non-constant holomorphic or analytic function, on a connected open set U, then z belong to U cannot be a relative local minimum. Relative local minimum of mod f of, unless f of z is 0. So it won't be a relative local minima. What is local minima? Do you know what is local minima? It will be, the function will be having minimum in that domain, in the set U, you can say. And one more theorem was just 1 second. Let us define one more term, that is meromorphic function. Before that, let us write some note. If f be an entire function, you can say non-constant entire function, then range of f is the following. It is dense subset of C. Range of f is dense subset of C. Second, it is open set. Third, it will be not bounded. Fourth, you can say range of f intersection R, it must be not empty. It is quite clear since it is dense set hai, so it is okay. And one more, you can say interior of range of f or image of f, that must be non-empty. Even this is also, these two people are clear from this since it is dense subset of R. What about this? What about this thing? If the range of f is constant in a straight line, then what can you say about f? As per that theorem, identity theorem, if your function is constant on any subset of that, then function must be constant in the whole interval. So f must be constant. F is constant function. Also, if f has uncountably many zeros, then also f is constant. Or you can say zero function if you want to talk about zero. If real part is bounded, then also f is constant, which I already told you. If real of f is bounded, then also f is constant. Correct? Okay, one more thing, one more definition, that is called meromorphic function. Like analytic, like entire, there is one more term, meromorphic. Okay, a function which is analytic, in a domain D except for the poles, is called meromorphic function. Actually we were using this function, just नाम नहीं दिया था इसको हम लोगों ने, but we were using all the time this type of function. Do you see what is your Cauchy integral formula? It was something like function upon z minus a, na? Or let me just take, say e raised to z upon z minus 1. What can you say about this function? Is this function analytic? No, because z equal to 1 is a pole for this function, correct? Z equal to 1 is a pole, but this function is meromorphic function, because meromorphic function is analytic except for the pole. So I can say this is a meromorphic function. This is not analytic everywhere. It is analytic everywhere except that z equal to 1, except for the poles. in particular domain D की जगह पे you can consider your complex number C. Or one more, if you want to write one more thing, you can say meromorphic function are precisely meromorphic function are precisely those which can be written as quotient of two entire function, quotient of two entire function, that is can be written as some p of z upon q of z. These two must be entire function. So an example you can say tan z. What is tan z? This is also meromorphic function. Why? Because this is sin z upon cos z. And one more thing, suppose you are having a transformation t of z equal to this az plus b upon cz plus d. Correct? This is called a Mobius transformation or linear fractional transformation. Then if ed minus bc, you see ed minus bc, if it is greater than 0, then the upper half plane is mapped to upper half plane. Upper half plane is mapped to upper half plane. What do you mean by upper half plane? इसको h plus से denote करते हैं. What is h plus? It is set of all z belongs to C such that upper half plane में क्या होता है? Yes, real part of z is always positive. Oh, sorry, imaginary part. Upper half की बात कर हम लोग. It will be ऊपर वाला part. Imaginary part of z is always positive. This is h plus. And what will be your h minus? It will be set of all z belongs to C such that imaginary part of z is your less than 0. So it is lower half plane. So if your AD minus BC is positive, then upper half plane maps to upper half plane. Correct? What if it is negative? If AD minus BC is negative, then this H plus is mapped to S minus. H plus is mapped to H minus. That means upper half plane will be mapped to lower half plane.